Welcome to Aerotech.
For decades, astronomers have speculated about the existence of a hidden object, possibly a planet, at the outermost reaches of our solar system. This hypothetical planet X could be the key to explaining some of the most puzzling phenomena observed in the distant parts of the solar system, where comets, asteroids, and even the trajectories of planets seem to be influenced by an unseen force. What was once considered a mere theory is now supported by a growing body of evidence, suggesting that something is affecting the orbits of these distant objects. Yet, despite advances in technology and observational tools, we have yet to directly observe this elusive body. But what could it be? Could it really be a new planet? Or is it something much more mysterious and terrifying, like a black hole, dark matter, or even an object from an entirely different solar system? In the early 19th century, astronomers began to notice discrepancies in the orbits of the outer planets, particularly Uranus. Though it had been discovered in 1781 by William Herschel, its orbit didn't quite match the predictions made by Newton's laws of motion and gravity. These irregularities led astronomers to suspect that an unseen object, possibly a new planet, was affecting Uranus's path. However, there was no direct evidence to support this theory, and the problem persisted for decades. In fact, the phenomenon was so puzzling that many scientists at the time refused to accept the possibility of a hidden planet, suggesting that the laws of gravity simply didn't apply in the outer regions of the solar system. But some astronomers, such as John Couch Adams in Britain and Urbain Le Verrier in France, would not give up. Using mathematical models and the principles of Newtonian physics, they attempted to predict the position of the unseen planet that they believed was responsible for the orbital disturbances. Through their hard work, they were able to pinpoint the likely location of the unknown planet. Eventually, their predictions led to the discovery of Neptune in 1846. But there was still one problem. The gravitational anomalies didn't completely disappear, suggesting that something else might be out there. In the early 20th century, astronomer Percival Lowell took up the mantle of searching for Planet X, convinced that a large, unknown planet was lurking far beyond Neptune. Lowell believed that this planet was responsible for the orbital anomalies not only of Uranus, but also of Neptune. He turned to mathematical calculations and used the best telescope of the time, his own, the Lowell Observatory's telescope, to search for the elusive object. Unfortunately, Lowell's efforts did not yield the results he had hoped for. While he was able to observe Pluto, another body that was later confirmed to be a dwarf planet, he did not discover Planet X. However, his observations did contribute to the larger body of evidence suggesting that something was out there. The search for Planet X became more urgent, and new technologies like more powerful telescopes began to be developed, fueling a renewed interest in the mystery. One of the most intriguing and difficult to study regions in our solar system is the Oort cloud, a massive spherical cloud of icy bodies that surrounds the solar system. This cloud is believed to be the source of many comets that enter the inner solar system, and it extends far beyond the orbit of Pluto. The Oort cloud is made up of remnants from the early solar system, frozen bodies that were cast out into space by the gravitational forces of the planets. However, recent observations suggest that there may be more to the Oort cloud than meets the eye. It is possible that an unknown object, potentially Planet X, is hiding within this distant cloud of icy bodies, affecting their orbits and possibly acting as a gravitational anchor for the cloud itself. While objects in the Oort cloud are difficult to observe directly due to their great distance from the Sun, it is possible that a large planet could be exerting a subtle but significant influence on the objects within this cloud. Some scientists have even speculated that Planet X could be an object that was captured by our solar system from another star, a rogue planet that was once part of a distant system and is now orbiting the Sun from a great distance. The discovery of Neptune and Pluto didn't completely solve the mystery of the outer solar system's gravitational anomalies. In fact, researchers have continued to notice strange, unexplained shifts in the orbits of trans-Neptunian objects, those beyond Neptune, especially those located in the scattered disk and the Kuiper belt. These objects, many of which are in highly elliptical or tilted orbits, behave in ways that are difficult to explain with the known planets alone. Some scientists have argued that the disturbances in their orbits might be the result of a large, unseen object, perhaps a planet, acting on their paths. This hypothesis has led many to revisit the idea of Planet X, especially in light of recent computer simulations. When scientists input the known orbits of these distant objects into sophisticated models and account for all known forces, the results are often inconsistent with observed movements unless an additional gravitational force is introduced. Many simulations suggest that a planet with a mass 5 to 10 times that of Earth could be responsible for these disturbances, though direct observation remains elusive.
In recent years, advancements in infrared astronomy have opened up new possibilities for locating distant objects in the outer reaches of our solar system. The James Webb Space Telescope, JWST, for example, is capable of detecting faint infrared signals from objects that are far too distant and faint to be seen in visible light. This is crucial because any object as far out as Planet X would be extremely dim and nearly impossible to spot with conventional telescopes. The key to finding Planet X could lie in its infrared signature. If Planet X exists, it would likely emit a faint glow due to its temperature and the minimal sunlight it receives, making it detectable through infrared observations. However, even with such advanced technology, finding Planet X is a difficult task. The vast distances involved mean that the object would be small and faint, and JWST's view of the sky is limited, covering only a fraction of the sky at any given time. The challenge, then, is to use the known gravitational effects of Planet X on distant objects to narrow down the search area and focus observations on specific regions of the sky. This is the same approach that led to the discovery of Neptune and Pluto, where scientists used mathematical models to predict the location of the hidden planet before it was directly observed. As our search for Planet X continues, we are faced with a disturbing possibility that the mysterious object we're searching for may not be a planet at all. What if Planet X is something far more terrifying and destructive, like a black hole or a mass of dark matter? A black hole, though far smaller than the supermassive varieties we typically associate with galaxies, could exist in the farthest reaches of the solar system, hidden from our view by its faint radiation and invisible nature. A black hole would have the gravitational pull necessary to disturb the orbits of distant objects, but without emitting light, making it nearly impossible to detect. Alternatively, it could be a mass of dark matter, an elusive substance that makes up much of the mass of the universe but remains invisible to us. While we don't know exactly what dark matter is, its gravitational effects can be observed, and its presence could explain the strange motions of trans-Neptunian objects. If dark matter or a black hole is indeed responsible for the disturbances, the consequences could be catastrophic. If the object's orbit were disturbed and it began moving closer to the inner solar system, it could alter the orbits of planets, potentially causing Earth's path to shift toward the Sun or out into space. If the object were a black hole, its gravitational pull could be strong enough to tear apart planets and possibly even the entire solar system.